Okay, thank you very much, Kate, and thanks very much for having me. And yeah, looking forward to these next few sessions over the next few weeks. We will kind of build on the theme, as Kate mentioned there today. We kind of thought we'd just start with a very kind of basic overview on soil health, and then we'll dive deeper into those more specific problems and themes next time round. So yeah, let's dive into the presentation, and we'll have a few questions and a bit of a chat afterwards. So we're really focusing all on soil health today. And when we think about soil health, that word health there obviously has a lot of kind of meaning around the health of, we think about health of ourselves, our bodies, or the health of plants, to be in good health, to be able to function, that kind of thing. And the opposite of health, if we think in that kind of context, is, obviously sickness, but also then soil degradation is perhaps a very common problem around the world. And there are some extraordinary statistics. I mean, there's different ones that you read in different publications and that kind of thing. But just for example, here, 1/3 of the world's soils are degraded, 24 billion odd tons of soil lost each year. I mean, like whatever the subtlety of maybe some different exact numbers and figures and that kind of thing that exist out there, it's certainly quite a staggering ballpark or estimate either way. And part of the reason, however, that's quite such a large number, 1/3 of the soil's being degraded, is that there are kind of many ways to define soil degradation before we even get into defining soil health. But and that's kind of part of the reason, is that really a degraded soil can be a soil that's suffering from various types of erosions, water, wind erosion, salinity, so excess buildup of excess salts, or even sodicity for that matter, excess sodium, loss of organic matter, which has been very common in many agricultural soils. Coming with that is a loss of fertility. Soil acidity and soil alkalinity is also a big problem in many parts of the world, but also even soil physical decline, so soil structural decline is soil compaction. This is what we'll talk about in the next few sessions. This is also soil physical kind of decline is a very important part of often what we think about when we talk about soil degradation, but also equally contamination as well. So there's kind of many kind of broad ways to ultimately define that soil degradation. And it's really quite I think this picture kind of really sums up this kind of fascinating fine line and dilemma that we face between soil health and soil degradation, soil sickness. We think about soil and all of the food that we grow from soil, how precious and how valuable this finite resource is, and how so much of our food comes from the soil. Yet once this precious resource, once this soil loses its structure, loses its stability, and then can begin to move and wash and erode or blow, very quickly something that's so precious can become such a pollutant once it enters the waterways, sediments, or the nutrients, or blowing off into the wind equally. So it's this kind of very fine line, how just depending on how, the place of that, where we find that soil in the field is precious, finding it elsewhere out in the ecosystem, it becomes very quickly a pollutant. And it's a very fine line, and that we kind of must walk between this delicate balance. And the reality is that soils do so much more than just provide food and resources for us, although of course that's very important, food and fuel and fiber, etc. Soils provide many ecosystem services, some of which kind of summarized here on this image. Of course, climate regulation and carbon sequestration, a topical one these days. Important nutrient cycling, okay, that's relevant for crops and ecosystems. Habitat for organisms, we'll talk about this briefly today. Flood regulations, so regulating waters and purifying waters, reducing contaminants, etc. Soils are a repository, a vast repository of vast genetic diversity that exists, particularly amongst some of the microorganisms. And many of those genetic resources are very valuable for us to find, for example, pharmaceuticals and things. Many pharmaceuticals on the market over human history have come from soil. And well, soil microbes and their byproducts. But and then we have things like soil for infrastructure, soil to use for construction materials, and of course things like cultural heritage or recreation. Of course, soils have recreational purposes when we think about them in the context of forests and natural reserves, etc. So they do many different things and provide many different services. And therefore, when we talk about soil health and trying to define soil health, it is rather a contextual thing. It's a subjective thing also, but it's also the context. It depends what is it that we're asking from the soil. Is it soil? Are we defining soil health in the context of agriculture and production? Are we defining soil health in terms of supporting the landscape and the ecology and the ecosystem and the waterways, etc., etc. So the context is different, and that therefore depends how we kind of define this. So it becomes can very quickly get a deep dive into some specifics and nitty gritty here. But the broad point is that it is different for different contexts. But this kind of broad definition that's often used from the US here, the capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. I think that's really the essence there, is its function. Is the soil able to function depending on what the goal is or what the context is in terms of what we require from that soil? But across those different contexts, the soil must be able to function for all of life, of course. So that's kind of, a basic kind of definition. And really the key idea then is that the thing that we really now see of soils as we are kind of going through this transition from, since World War II, we've had that very strong focus on production. It's been very focused on agricultural productivity, using science and technology, fertilizers, etc., to grow better crops, to simply grow more food, to be more productive in a post-war era. That was the kind of the intense focus. And yes, we've become very good at that, at producing, but not necessarily providing some of those other ecosystem services that we were talking about earlier. And if we compare that to a natural ecosystem, well, it is very good at providing a lot of ecosystem services, but maybe it's not as productive from the food point of view. So, in terms of this kind of moving forward in agriculture, and therefore when we define kind of this multi-contextual kind of definitions of soil health, is this kind of key word there, multifunctional. That's really what we need out of our future production systems. Is yes, they need to be productive, but they also need to bring other co-benefits. They must also support other ecosystem services as well. And really that's a lot of the kind of the thinking now, bringing some element of ecological design into the agricultural production system to try and just find a better balance here between these two and achieve a better state of multifunctionality. So if we then kind of move on to say, okay, more specifically, when we talk about healthy soils, what are the parts of this? What are the pieces of the puzzle that we're referring to? And really this classic kind of definition of soil health typically encompasses these kind of three strands: the soil chemical properties, the soil physical properties, and the soil biological properties. And the soil chemical properties, of course, include things like the nutrients, the nutrient availability, how well nutrients are cycling, the pH, the acid or alkalinity of that soil, and the cation exchange capacity. So talking about how big or light the soil is, how much moisture and nutrients it can store. And from chemistry, we also have the physical aspects. So here we're talking about the soil structure. And this is where we're really going to dive quite deep into this strand, this leg of the stool, in the next two presentations when we talk erosion and compaction, because both of these problems are very strongly linked to soil physical degradation. But of course, they're all interlinked, as we will also discuss. These things very much overlap. And so, yeah, soil physics, we're talking really about how well the soil is aerated, how well it can therefore exchange gases, how well oxygen can get into that soil, how well CO2 can come out in order to support the cycling. But also then the drainage of that soil, how well the water will get into the soil, infiltration, but also then how well that water will percolate and drain out the bottom of that soil. And that's all to do with aggregation, how well the particles are aggregated, how well we have good pore space and pore space connectivity. So that's your physical properties, and then the biological properties, the living component of the soil. And this is from the microorganisms all the way up to insects, small and larger insects, and up to the earthworms and onwards into the other small animals of the soil as well. So that there we have all of the living component. And really the key message that you can kind of comprehend with the three-legged stool here is that with this analogy, of course, if one of these legs is not sturdy, if we haven't been paying enough attention to managing it properly, just like the stool would be unsteady with a wonky leg, equally the potential of our soils is equally going to be limited, because one of these, there's a weak chain in the link here, and one of these parts of the pieces of the puzzle is perhaps not functioning to its full capacity. So overall, dragging down the overall health and functionality of the soil. So the three-legged stool, I think, is a very good analogy that kind of sums that up. So just a few points quickly into each more of these. When we talk about then the chemistry, of course, we're talking about the nutrients that supply crops and plants, which ultimately supply animals and grasses, etc. And so we've got to support good nutrient cycling so that the plant can obtain nutrients. And just to point out really that nutrients in the soil, they do exist in many different forms. There's a very small fraction that's in the soil water. That's the soluble pool. That's the nutrients that are in solution in soil water. And these are very easily, very rapidly taken up by the plant. But we also have a slightly larger fraction of all of the nutrients, all of the macro and micronutrients. These are called exchangeable, and these are the ones that are kind of sitting on the, kind of stuck on the soil surfaces. Soil particles are all negatively charged. So we have, for example, these positively charged nutrients that are holding on, being held to the soil surface. And these are also relatively available as well. The plant can exchange these and take them up. So you have these kind of two pools of nutrients that are fairly available to the plant, but there is also a third and much larger pool of nutrients. This is called the total pool. And these are the nutrients that are present in the soil, but they're not actually immediately available in the short term. So they are potentially available over time, but often some of those are just embedded within the structure of the soil, the clay mineralogy, etc. Some of them are maybe still not fully weathered from the parent material, and some of them are kind of locked up. Nutrients have all sorts of interactions, both positive and negative. Some nutrients, for example, positive nutrients and negative nutrients, so cations and anions, these are called, they're attracted to each other, and they bind to each other to form insoluble and unavailable kind of forms of nutrients. So, just to point out that within that context of thinking about soil nutrient supply, there are these different pools, and it is important to kind of understand them all. And what we do see is that many soils, particularly the loamy and clay soils, not so much on the sandy soils, but particularly the heavier soils, they do have actually quite a lot of nutrients in the total pool, very significant amounts that just needs to be unlocked, cycled, harnessed through plants and through microorganisms, which we'll talk about in a second. And then, of course, things like the soil pH are really important. It's a piece of the puzzle to measuring how acid or alkaline the soil is. And if it's very acidic, we get drops in nutrient availability. Equally, if it's very alkaline, we can also see certain nutrients really reduce in availability. And so we have this kind of rough sweet spot here between kind of 6 and 7, kind of 7.5 max, really. Kind of through here, you can see fairly good, generally good availability for most of those nutrients. And then soil texture, this is kind of moving on to a little bit on soil physics now. The soil texture really refers to the size of the particles. So are we talking about sand? Is the soil made of mostly sand, so very large, coarse particles? We have silt particles, which are kind of more medium-sized, and we have the clay particles, which are very, very fine, very small. So that's really just telling us a little bit about the makeup of the soil. And of course, the larger the particles, the more coarse, the more sandier the soil. That means it has a lot more pore space. That means it's a bit harder for it to hold on to moisture and nutrients, whereas clay soils, which are very small particles and very, very fine, very closely located, they have better negative charges. They have better forces there to kind of hold on to and bind to moisture and nutrients. So nonetheless, that tells us a lot about the soil properties by considering the soil texture. And also the soil structure is another part. Then we talk about, well, how soil structure really refers to how those particles are then arranged. So we can have sandy soils or clay soils, but then how those particles kind of stick together and link together ultimately also influences the structure. And here's just, for example, a nice crumb structure. You might have heard this word before, a nice crumb structure. This is a very good example of how the particles are very nicely and evenly kind of spatially structured, creating pore space in between, etc. But we have a range of different ways in which the particles can also be arranged. This one is quite common. We'll talk about this platy structure. If we see a lot of these flat and horizontal lines, you can see this is typically a particularly important sign of compaction that you can kind of see. So that's something to be concerned of. Here we have very fine sandy soil. It's harder for sandy soils to aggregate quite so well because they're very coarse and sandy already. So we'll talk about this a little bit in our next presentation, but just to say that really when we talk about then soil structure, it's really just about how those sand, silt or clay particles are physically arranged and stuck together, and sometimes it can be very tightly leading to poor structure. Sometimes we can see we have various gaps and cracks and crevices here, which can be more conducive to gaseous and water exchange. And then there's the soil biology, and this is, as I say, the life in the soil. And here's just some images to kind of support that. We have the microorganisms here, bacteria, single-cell organisms. We have fungi that grow in these long strands or threads. You all know fungi is mushrooms, of course. Mushroom is the fruiting body of the fungus. The fungus grows underground with these strands or threads. Called hyphae. We also have protozoa. These are single-celled little animals. They kind of swim around eating bacteria and eating particularly bacteria, but also eating lots of other organisms, bits of fungi. And they're the grazers of the underground world. And we also have nematodes, microscopic little worms. Some of those are bad, the plant parasitic ones, root-feeding nematodes, and some of them are beneficial nematodes that can actually support can actually suppress the bad ones, but also support generally nutrient cycling. And then we have our insects, for example, some small insects and bigger ones. Insects are very important for shredding organic materials and residues and breaking them down, burrowing, mixing soil particles together. And of course, the earthworms are very good at doing that as well. You can see they leave these nice channels and tunnels through the soil particles. Great for aeration and structure. And then we have also a special fungus over here called mycorrhizal fungi. And that's a special fungi that doesn't just feed on organic material and crop residues and plant residues, etc., but it actually forms an association with the living root of the plants, colonizes that root and grows out. And the plant photosynthesizes, sends sugar down, and the fungus uses that to grow. And then it will solubilize nutrients and access moisture from the soil and deliver that back to the plant. So these are, just, for example, some of the organisms, and really they come together in this broad community, often called the soil food web, which just highlights that they're all very interconnected and they're all eating each other. And every time they interact and eat each other, they are like us. When we eat, we process, metabolize, and we excrete waste products, and they do the same too. So as they kind of interact and spit out their various kind of eat each other and spit out their kind of various waste products, these are all forms of nutrients that the plant can take up. So the microbes in the soil, the biology of the soil is really important for cycling nutrients, taking nutrients from the soil particles or from the decaying plant residues or from animal manures, etc., and eating that and breaking that down and then excreting all of the waste products, which ultimately are nutrients back for the plant. But again, the point here is just to say that really it is this process of photosynthesis whereby plants will breathe in carbon dioxide in the presence of sunlight and turn that carbon dioxide into their bodies, into their biomass, into their roots and their root exudates, and they will deposit these into the soil. And this is the organic matter, the carbon, the crop and plant residues, animal residues, that ultimately is the key food source. It's the fuel of the food web, feeding all of these organisms as those nutrients pass their way up through the soil food web there. So that's in a nutshell, just really quickly, some of the core ideas of soil health. It's this kind of bringing together elements of the nutrient availability, the soil structure, and then the living components of the soil. And we have this kind of classic idea, you might have heard this saying, feed your soil and it will feed you. And this kind of conjures up that importance of soil care and soil nurture. Take care of the soils, feed them with some organic matter, compost, manures, etc. Feed the life in the soil and let them bring the benefits of nutrient cycling, etc., and soil structure and soil gluing soil particles together. And it's got this idea, this kind of conjures this notion of if we have healthy soils, we will have healthy plants. That, from healthy soils, healthy plants grow. It's this kind of idea of really putting a soils first approach, saying, let's get the soil right, let's get the soil healthy. And then when we try to grow plants in there, plants and animals in there, they will also be healthy. And of course, that's the classic kind of view. And I think that's right, a good, accurate view. But we also have this kind of emerging view around this slightly different, opposing, but complementary view, which seems to be somewhat linked with a lot of the regenerative agricultural movement to some extent. But it's this idea that that actually, soil, as this quote captures the essence perfectly, soil without biology is just geology. And what we're really referring to here is actually that soil, the process of soil formation is actually very much a biological process. It is the action of biology that form onto geology, onto rock, onto parent material that ultimately forms soil. And when I say biology here, I'm really referring to plants and then all of those living organisms we heard about just before. And really that's the idea. It says, well, okay, if we just had parent material, rock, after a volcano, what happens after volcanic activity or geological upheaval? Typically, we see this process of soil formation that begins, and we have life that begins to grow on the rock. And here I'm talking about things like mosses and lichens, bacteria, some of the algae. So organisms begin, but microorganisms grow on the rock. And as they grow and die, grow and die, grow and die, grow and die, they begin to deposit their bodies, build carbon in that rock through weathering processes, additionally releasing nutrients. We start this kind of process of soil formation. And this happens over, of course, many millions, thousands, millions of years, to the point where we start to form a bit of soil. Organic debris is building up, mixing with some of that rock. And we can have some plants move into that system. Some higher plants kind of move into the ecosystem. And again, they all grow and die, deposit their organic materials. Again, enhance soil formation, build up soil depth over time, to the extent where, again, that carries on all the way through to once we then form kind of deep soil. So the point here is to say that actually, if it wasn't for biology and the action of biology on the geology, of organisms growing and dying and interacting, that actually we wouldn't be forming the soil. And of course, the perfect example here is the moon or Mars. We have geology there, we have parent material there, but we have no life. So therefore, we don't have good soil. We don't have soil formation, so to speak. It just remains as geology. And so that's a little bit in reverse of our kind of previous thinking. That was like, well, if we get the soils right first, if we make the soil healthy, well, then the plants will be healthy. But here we're kind of pointing this idea that this opposing view says, well, actually, it's how we manage plants and what plants grow and what plants do that actually is also going to influence how healthy the soil is. And really, this is kind of the idea then of things like green manures and cover crops, using plants intentionally to grow them to help to improve and restore soil and soil fertility, etc. And so when we say biology, the action of biology, just to point out that yes, all of those microorganisms and insects and earthworms are very important to this process, but really it is plants who have the capacity to photosynthesize, who can breathe in that carbon from the air, turn it into their bodies, so that when their bodies die and return, that provides the fuel, the food for that food web, for all of those organisms to then grow and die, and then again accelerate and drive this process of formation. So it really is plants at the top here that really are central players. And it's, again, this is just the opposite to that view that says, well, get soil healthy and we'll have healthy plants. And here we're saying, well, actually, we've got to optimize plant photosynthesis and plant growth, and they will also help form soil. So I think it's very fascinating. It's just a slightly different but very complementary idea in terms of thinking about soil health and how we manage soils. It's not just that plants are an expression of the soil and the soil health, but also it seems that the soil is an expression of the plants, of the plant health, of the biological activity. And in this process that I just talk about through soil formation, etc., it really is roots and root exudates that are really important in this. It is what's happening below ground. Yes, above ground, the plants are photosynthesizing, capturing that carbon, but it's being sent down to the roots and to grow root biomass and to be excreted. Some of that products of photosynthate, those photosynthetic products, are excreted out of the root systems as these root exudates. And this below ground root and root exudate component is really important for soil health and for driving soil health, for driving soil formation, et cetera, et cetera. It really is a huge part of what's going on below the ground that's really important. And those root exudates are hugely diverse. Some of them are acidic compounds that help the plant access nutrients, strip and solubilize nutrients from the soil, like we were talking about before. But some of those root exudates are sugars and carbohydrates, amino acids, all sorts of other compounds that actually are designed to feed the biology, feed those particularly microorganisms growing around those root systems, and to ensure that the soil biological health is functioning, and so that those organisms can also help to strip minerals and make nutrients available. So this is really why the plant sends all that carbon down there and then excretes it out of the root system, is so that, yes, so that it can get nutrients and unlock nutrients from the soil, but also so that it can feed the biology and let them get the nutrients from the soil, because they're very good at it. The microorganisms are much better at doing this than the plants are directly. And so that's the core of the idea, is that really if we are having a conversation about soil health, if we're thinking about soil health in any kind of context, actually your focus really needs to be below ground. It really is the penetration of those roots that you can see that help to stabilize soil, restructure soil, and then as those leaky roots excrete out those exudates, then we are feeding biology, driving nutrient cycling, supporting further photosynthesis, and overall improving the soil health. So again, just summarize, it's this point here that it brings this context of the action of plants from the top-down approach, through photosynthesis, through roots, that this from the top-down approach, that plants are actually really key drivers of soil health as well. And so therefore, it's just really important to know what's going on below the ground. Dig up your plants, have a look at the roots. Don't just walk through the field or through the pasture and have a look on top. you want to get down and see what's the roots look like. Are they big? Are they small? Are they fibrous? What are they doing? How well is the soil sticking to them? If the soil falls off very easily, that's not a good sign. If the soil sticks to the roots very tightly, then that is a good sign that there's better overall soil functionality there. So yeah, key message, don't forget those roots, get down and have a look at those roots. And here's a nice example here. This is a cover crop. And this is a photo from Scotland, actually, that was taken in around November, so quite late in the season. And yeah, you can see here that this cover crop is pretty small. This is the same field, same day. On the the left in the middle photo, yeah, the cover crop is only whatever, a few inches tall or so. It's not a big biomass cover crop. It is only quite small, but however, this photo on the right, you can see, I look at that and say, yeah, that's got a very good, healthy, functional root system on all that soil is sticking to the root system. That's what we want to see. And there's some pretty decent root depth there. So despite it being maybe not so big on top and not so showy and flashy, I would argue that, yeah, this field is doing some good. There's some good soil health functioning here. There's some good soil protection. And I can see those roots definitely providing benefit to the soil chemistry, physics, and biology, etc. So I think don't judge the book by the cover. Make sure we have a look at the roots too. And really, that's, you know, one of the easy ways to also support this process of soil health and soil formation is perennial agriculture. You know, perennials, they produce more roots. They allocate more carbon below ground. Annual plants do not. They have smaller roots. They prioritize above ground. They don't prioritize as much below ground. So really, the more perennials you can grow in the system, the better. And arguably, this is one of the reasons that we've seen a lot of soil degradation and soil decline in recent times, is that it has been this transition of agriculture from perennial-based systems or much more mixed farming systems into more annual-based, you know, cropping systems, where we've lost roots, and therefore we have lost soil health through that process. So yeah, this idea then of soil health as a combination of the three-legged stool, the three parts there, the chemistry, physics, and biology. Really, the take-home message is that really we need to widen that lens and say, look, we really need to bring plants into the picture. It is the role of plants. And those roots and root exudates especially, that influence the chemistry, the physics, and the biology. And indeed, the biology, the chemistry, and the physics and the chemistry also influence that plant. Yes, it's a two-way street, is the take-home message. Okay, yes, it goes this way, but also it comes top-down as well. So really, how we manage plants is key. And this practically means how you manage, for example, plants in a pasture, how you manage the grazing and the rest periods, how you manage the plant diversity. It would be true in a pasture or a cropping situation, how you manage the monoculture versus maybe a little bit more diverse intercropping type systems. But also we could define this through plant nutrition, how you optimize the nutrients in the plant, the macro and micro minerals that are important for photosynthesis. So how we manage plant health from a plant nutrition point of view, from a plant diversity point of view, and from maybe a grazing management, where relevant, point of view is really important, because how we manage these plants then ultimately drives a lot of these interactions down below in the soil. Okay, so in summary, how then can we best support soil health? How can we increase soil health? And I'm really going to take a very strong focus on roots here. Roots are so central, as I've touched on. So how do we support roots is kind of how we support soil health. And in terms of the context of, say, amongst cash crops, it would be that easy answer, grow more roots. So choosing varieties or maybe crop species that are good root biomass producing plants. And some of those, for example, of course, would be things like alfalfa, timothy grass would be another one. But also, you know, plants that have different roots too. I mean, cereals, they have good fibrous roots. Some of our others have good more tap roots, okay, like the tillage radish, for example. So, you know, you could kind of, again, choose a bit of plant species diversity there and have plants with different root systems, different and complementary root systems. But as I touched on there already, I mean, wherever you can bring perennials into the system, the better. A perennial now that could be transitioning some of the farm to permanent pasture, but even within cropping rotations, it could just be having perennials within the rotation, having a perennial phase for 2 or 3 or 4 years, and then going back into cropping, for example. So anywhere you can bring perennials into the system, the better. And longer term, definitely we have the opportunity for breeding new varieties for below ground traits. We can breed varieties that have bigger root systems, which will support this process of soil health, supporting soil health. And then that soil health principle of maintain a living root, I think, becomes really important. Because if you have a living root in the soil 24/7, then you have photosynthesis, then you have those carbon compounds coming down and being excreted out into the soil. And so anyway, you can maintain a living root, the better for soil health, because of that carbon constantly coming in and being exuded out through the root systems. So cover crops, that's all about extending the season. Can we grow cover crops after harvest and have a living root through the off season? Maybe relay intercropping also could be an example of that. And really the goal is just to avoid bare fallows wherever you can. Polycultures, that's more diversity. I touched on that briefly. Just roots are valuable, and therefore if we have a diversity of roots, the better. They all do different things and have different growth habits and patterns, etc. And again, we could use companions or intercrops for some of those below ground benefits. So using a companion for its rooting and growing that with a cash crop for its yield and for its production. So a good kind of balance there between those two. With cover crops, again, it's about growing more roots. You just want to choose plants or species and varieties that have more roots, for sure. And particularly legumes are good in cover crops. They have a very good high quality litter, so a low carbon to nitrogen ratio that also supports good digestion and good feeding of the organisms to help a lot of these processes as well. And additionally, you know, there can be some inputs that can be used to support soil, root production. So certain nutrients are very important for root biomass production. So things like phosphorus, boron, sulfur, calcium is also quite important. These are nutrients that can enhance rooting development. And but equally, there's a whole range of other things these days, biostimulants and biofertilizers, that can also support good root biomass production. We definitely want to minimize disturbance. So that's really about preserving soil structure. And we'll talk about this in length in the next couple of lectures. It's all about maintaining aggregates and the stability of those aggregates, maintaining pore space in between. And so really, however you can minimize tillage, the better, be that maybe no till, maybe it's min till, maybe it's a strip till, maybe it's only rotational strategic tillage at points in the time. So wherever we can embrace that principle, the better. And then livestock integration always helps too, particularly some of the kind of more rotational holistic style grazing where we give the plants longer rest periods. That means more root recovery. And of course, more root recovery is really important because roots are such central drivers of soil health. So, so those kind of grazing styles are very beneficial. And then it's really about that diversity again. So if we can use a bit of multi-species pastures or more diverse pastures, more species diversity in the pastures, then the better. We will have some different plants with different specializations, different benefits. Some may be deeper rooted, some more shallow, some doing different things, etc. So across all of that, we get better multifunctionality from those plants. Okay, that was it. Let's see if we have any questions.
Thanks, Joel. Yeah, if anyone has any questions, you can feel free to unmute yourself, or you can enter them in the chat as well, and I can read them out.
Hi there. Thank you for your presentation. It's very interesting. What kind of diversity can we bring into a pasture? I have 9 acres with a few horses. So of course, do my best to rotate and all that, but compaction is a big issue. I was interested that you said the more perennial things we can have is better long-term, but I feel like I need to plant something that's gonna sort of break up that compaction. And from what I understand, like a fall ryegrass will do that, which up here is an annual. But yeah, sort of interested in what you have to say about sort of pasture compaction with what we've got up here, and that we can't sort of have stuff growing over the winter to make up for what's going on in the summer.
Yeah, yeah, of course. It's always a challenge in the northern climates, and put it this way: if you are suffering a bit of compaction there, the key is having some species that have deeper roots. And so often, a lot of simple pastures can be kind of ryegrass dominated, and yes, ryegrass is a good plant species to have in the mix, and it's generally a good productive species. But the reason it's productive up top is because it's not so productive down below. There are trade-offs. So it's not great at growing big roots and therefore helping with compaction type problems. So a mixture of grasses, I would throw in some timothy and cocksfoot, for example. Lucerne again is a good deep rooting plant, and other things like chicory or plantain could also be good options. They've got pretty good tap roots on them as well, and really some of those other species bring different nutritional benefits, particularly the chicory and the plantain. They have a lot of medicinal compounds in there that can actually really support animal health and gut health in the animal and that kind of thing as well. So I'd consider some of those, and yes, to your point, of course, ryegrass is fall rye, etc. Yeah, this also has good root system on it as well, and I know that some of the species are not so persistent through the winter time, and you're right. I'm not opposed to the use of annuals in this purpose either. And I think annuals, they can have very good benefits in terms of kind of kickstarting the system and rapidly kind of get things going, and kind of giving short bursts of benefits. So I would agree that annuals can be useful. It's just that you really, and I think they can be useful over successive years, because what they struggle is that annuals need a bit more time for some of their benefits to come in, to come to fruition. And so under very short growing seasons like you have, of course, I realize it becomes a real challenge there. And that's where you need then repeated bursts of these benefits to kind of slowly create a succession of kind of repair. But those kind of annuals can be good to kind of start that process. But I would argue that longer term, you do really need to think more about and particularly if you're a pasture situation anyway, like about some of those other more perennial style plant species that can, once established, will also persist a bit longer. And then key lastly is just your grazing management. If you can, you've got, and I know you can only do this based on the number of your stock and the land that you have, but you've really got to do good rotation to give the plants more time for root recovery, as I just briefly touched on at the end there. It's really important. You don't want to come back and regraze again. That's what's really keeping the grasses short and the pastures short, is what's going to keep their roots short. So moving the animals on and giving certain fields a really good rest and recovery so they can get lots of regrowth, lots of tall growth. The taller above ground, the kind of the deeper the below ground. as a general rule. So yeah, definitely your grazing management is an important part of this, and try and give the fields as long a recovery as possible. And if that's a challenge, a bit of a challenge for you, then just choose some of the fields, a field or two, or like the fields that are the worst, for example, and really prioritize them as giving them a good and lengthy rest period, and try and work, kind of graze elsewhere to give that really good rest and recovery period in the poorer fields, as more of an urgent and drastic kind of recovery strategy. And then when you come back to that, you know, you could then choose another field next time round to kind of give that a really nice long rest period, to try and restore its health as well. So I know that the rotational thing can be tricky, but I would say that key to realizing the benefits of roots and decompaction of roots and this whole thing we talked about, key to this really is ensuring that those plants have good root recovery through long rest periods with not too much repeat grazing. Anyone else, feel free to chime in.
I'll ask a question. So if someone wanted to have an assessment of their soil health, or if they were curious of the overall health of their soil, what would be kind of the first steps that they could take to check that? Yeah, what would you recommend?
Sure. Yeah, that's a good question. And, you know, I would say there are some simple and easy kind of even in-field assessments, like cheap and easy in-field assessments that farmers can do. And so, for example, things like the infiltration test, which you could Google that one. It's easy, just kind of getting a ring and pouring some water in. I mean, there's a bit more to it, but and just timing how quickly the water will infiltrate into the soil. Things like that, they're just basic, you know, in-field tests, but actually to give you a snapshot of kind of many of the overall functions, because the chemistry, the physics, and the biology, they're all very much interrelated. And so something like the infiltration test, I think, is a really good general one. It gives you a bit of a snapshot on all overall soil health. So that would definitely be one straight away. And things like that aggregate stability test as well. So popping a little aggregates into some water and watching how well they stay together or how easily they disperse also can give us some idea about the soil structural integrity. And although both these are perhaps measuring more the physics, they are quite important ones that actually tell us a lot about the biology and the chemistry as well. So some things like that would be some really kind of easy in-field things to start with. But beyond that, if you were looking to do a lab test, as I kind of alluded to really in the theme of the presentation, the content of the presentation there, it's a lot of the soil health tests nowadays, and rightly so, they try and integrate a little bit of chemistry, a little bit of physics, and a little bit of biology. And I do think that's good. You're trying to get a little snapshot of all three of those, and then kind of integrate them together into an overall soil health picture kind of thing. So I think there is no one magic kind of thing to test for. The best answer is a bit of an integration of a few of them. That's rather than kind of just to say there's one thing that's the most important or that kind of thing. So integrating a few of them together is good. And yeah, that could really be, as I say, from the physics point of view, the couple I mentioned, or when the lab test, they would do like a soil texture type analysis. From the chemistry, yeah, you could look at the nutrients and look at the pH. And then from the biology is a bit harder generally to study. We still know so less about the biology, but you could measure things like microbial respiration, like the CO2 evolution. You can measure microbial biomass to see how much of them are there. Some of these kind of basic tests are also okay. So yeah, there's a lot of labs kind of doing soil health tests now, and really that's a lot of them are very similar in that sense. What they're really trying to do is piece together pieces of all those puzzles, look at them a bit more holistically, and try and determine soil health from those multitude of tests, basically. So I think then lastly, kind of beyond that, I would just add one small comment to say that also things like, again, that point about plant health as an expression of soil health, you know, we can also measure the plant itself to gauge the soil health. So using things like a plant analysis to measure the nutrients in the plants. If the nutrients are all good in the plant, then clearly things are functioning. And we can use other in-field tools like, for example, a refractometer or a Brix meter. And again, these are a bit crude and kind of basic tests, but for an in-field, quick and easy assessment, it still gives you something. And it's really measuring how well the plant is photosynthesizing, how much sugars and carbohydrates and compounds it has in the plant sap. And again, it's just that point that, okay, if plants are indicators of soils, then we can kind of assess soil health through plant health as well. And that can sometimes be a little bit easier as well. Yeah.
Great, thanks so much. Does anyone else have any questions before we end off for the evening?
Sorry, it's me again.
Please, don't worry, please.
This has been my my fun project on our land for the last few years, is trying to rehabilitate it. So
yes.
Yeah, I'm pretty excited about it. I've read that sort of trying to introduce more fluff into your soil, for lack of a better word, by mechanical means isn't really the way to go. It's better to do it through plants. But do you maybe need to sort of start with that sometimes to be able to even get that soil contact with the seed? But how far should a person go? Is it just really try a bit of aerating, but not rototilling, that kind of thing?
Yeah, good question. And yeah, you're right. I mean, there's many different views to this. People have all sorts of different opinions on this one. And I agree with the general sentiment that yes, of course, roots and using plants is the best answer, using those roots and those plants. And we can say for sure that, you know, the cause of your compaction issue, the root cause of that compaction issue is definitely not a deficiency of tillage or a deficiency of subsoiling or you know, a deficiency of the machinery. It's obviously something else is wrong, which is why the soil is compacted. It's not that there's not enough machinery in the ground. So if we make that assumption to begin with, then obviously, therefore, machinery is never going to be the answer, the core of the answer, the root cause of the answer. However, does that not mean that a bit of machinery can still be used, as you're suggesting, in a strategic way, perhaps a once-off, to just help catalyze and kickstart the recovery? And I think that yes, something like a subsoiler to kind of get a deeper piece of kit down into the soil, which can kind of help to fracture and crack open the soil. Maybe not so much the rototilling that you're mentioning. That's kind of perhaps more of a surface mixing, but really you just want a deeper kind of shank going down into the soil to crack open the soil at depth. And however, the key that needs to happen with that process, it's not just about doing that as a one-off and then you're done. That is really just your catalyst to get started. You still have to address the root cause of the problem. That's going to help you crack open and alleviate some symptoms. You're doing important symptom treating at that point in time, but you're not addressing the root cause. And really the root cause is a lack of roots, a lack of deep roots, and you've got to get them roots down there. So yes, I agree that a mechanical intervention to catalyze, to crack open that soil can be a good first step. But you then have to encourage good rooting down into those cracks and get good roots down into that soil to then stop that soil just simply recompacting and restructuring. And so that might mean overlapping these techniques that we mentioned. So, for example, yes, if you were trying to do some reseeding and put some deeper rooted pasture species in there, like the Timothy or Coxford or Lucerne, for example, to get those deeper rooted species in there, yes, I agree that they might establish better, and that you might get a better stand and establishment of those if you mechanically disturb that soil first, just to kind of crack it open, and then get those roots down there. I think as long as if you do it that way, then I think absolutely fine to have some mechanical intervention. What you don't want to do is just do the mechanical intervention, and then if you don't get roots down there, if you do nothing else but just that, the compaction is just going to come back. So you've got to come back and address that root cause, and that really means getting roots down at depth, but also then managing the plants on top through your grazing to make sure those roots get down there and also stay down there. So again, good grazing comes into that. So long recovery rest periods is important there as well, to then just prevent the soil from just kind of slumping back otherwise. So yeah, I think a bit of mechanical intervention is fine, but just make sure you couple it with some rooting as well, good roots as well.
Awesome. If there are no other questions, then I think we can call it for the night. Next week, the webinar will be focusing on soil erosion, so can get a little more in depth with those issues as well. So yeah, thank you everyone who's joined us tonight. Again, this will be up on our YouTube channel in hopefully a couple of days. But yeah, thanks so much, Joel, for all that information. That was really great. We appreciate it.
No worries at all. Thank you for having me, and yeah, look forward to next week.
Awesome. Thanks everybody. Have a great night.